In this video, we will generate the dataset of the decaying sine, which is in the form of e to the minus vx times sine wx, where the value of v is 0, 0.4, 0.5, and 1. So data validation, list of items, that is from 0.4 to 1. So copy this and paste it and save. We can start with 1. Likewise w, which is data validation, list of items, and will be 1, 2, and 2.5. So 1, 2, and 2.5. And save. We can start from 1. We will have the same for the expansion. So we copy this and paste. But we'll change this to red. This is for the expansion, while this is for the function. Now we can continue with the dataset of the decaying sine, which is array formula, exponent minus v times x. That's the first part. Times sine wx, so sine w times x. That's the dataset of the decaying sine. Now the Taylor series expansion, which is the summation of a times x to the power n, where n starts from 0 to infinity. 17 is good enough. The value of a, you can post your email address in the comment section to access the complete version in private of this video. Now we continue with the expansion, which is array formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1, and the coefficient will be this range, and enter. Now we can chart this. Insert chart, and we use scatter chart. Use column as label. We don't need a title because we need a space. And for the series, we show the trend line. The type of the trend line, polynomial. The degree, 8. For the label, use the equation. And for the legend, position at the bottom. So here's the trend line and the polynomial of decaying sine and its polynomials. Next, we continue with the changes of the values of v and w. Before we do that, we compare the polynomial regression coefficient. Coefficient of x to the 0 is 0 because 2.68 times 10 to the minus 0, and 3.18 times 10 to the minus 30, minus 32, so this is 0 already. Coefficient of x, 1. Coefficient of x squared, negative 1. Coefficient of x cubed, 0.334. Coefficient of x to the 4th, negative 6.21 times 10 to the minus 4, negative 6.17 times 10 to the minus 4. Coefficient of x to the 5th, 0.0328. Coefficient of x to the 6th, 0.011. That is 0.011. And coefficient of x to the 7th, negative 1.68 times 10 to the minus 3. Coefficient of x to the 8th, 1.09 times 10 to the minus 4. And we will change this v. Let's say we change this v to 0.5. We have to change the expansion also to 0.5. Now they're the same. Suppose I change this to 2. So this is our decaying sine. Now the expansion will change it to 2. Now they're the same. Suppose I change this to 0.4. I can change this also to 0.4. Change this to 2.5. So we have shortened the wavelength. We can also change this also to 2.5. Now they're the same. This completes the use of Taylor-Maclaurin series sum function, LINEST polynomial regression, in showing the trend line and polynomial of decaying sine.